All right, so let's continue where we left off. Well, the previous video is uploading. Um, the first thing that I want to do in this process is I want to clarify to GPT-4 that I only want JSON. Please. So, yeah. Okay, my story. Since this is going to be machine read, please return only JSON. Usually that works with GPT-4. Mistral AI is a little bit more stubborn. It really wants to elaborate. So, yeah. That should be good. Now, I'll show you this little utility that I wrote last night. If I can remember what I called it. Open in Explorer, date modified, last night, permutations. That sounds about right. So, permutations. Now, what I did was I wanted to figure out what the best words to focus on teaching were for understanding stories, because now I have several thousand stories. It's like, okay, well, what am I going to do with them? Well, we're going to use them to teach English. That's the idea. But which words do you want to focus on? It can make a big difference how much a student is able to understand. Now, I'm not actually sure if the problem is NP complete. It certainly looks like a few NP complete problems, but maybe there's something I'm doing with the scoring that changes it or something, or gives us a heuristic that makes it easier, but whatever. I'm just treating it as though it's NP complete. So I came up with an algorithm where we would create sample sets of words, and then we would figure out which the best one was. So I want to start with a dog and a cat story. So I look for stories that mention a dog but not a cat, or a cat but not a dog, and I call those dog exclusive and cat exclusive. And then what I do is I generate a sample. So I say, take my one dog exclusive story, my one cat exclusive story, all of the files, how frequent our parts of speech counter, and the minimum number of occurrences. So if a word doesn't appear in enough stories, I think I said it like 15 or something. Where is it? Yeah, 15. If it doesn't appear in enough stories, then we don't even consider that word. So it goes through, and we're trying to generate 150 parts of speech, and we generate 1,000 samples. Now, I was thinking about experimenting with, swapping out words and seeing if we could evolve it, and I don't know if it's worth it. I mean, at some point the student just needs to learn all the words, and I'm just trying to get a rough idea of which 150 words we should start with. So a dedicated student is going to stay a few months longer. They're going to be past those 150 words anyway. But generating more samples does seem to help. But let me just set this smaller. So what it does is it randomly adds stories. Now it's treating them as a set. So it's only adding unique parts of speech up to 150, and it has to be exactly 150. And then what it does is it takes every one of those samples and compares it against every story, and it figures out what percentage of the words the person knew, based on the chosen curriculum, and then it squares that's the square right here. And then it adds it. So, like, if it was 80% retention rate, then you would get 0.64. If it was 100% retention rate, then you'd get 1.0. But if it was, say, 50% retention rate, then you'd only get 0.25. So the closer you get to 1, the better it is. So I want words that help you understand a large number of stories, understanding that there is going to be some sort of specialization. Some words go together where other words do not. And that's why I want to focus on having dog and cat stories, because, that's supposed to be my marketing thing. I'm not very good at marketing, but making a product for humans, right? So let's see here. Quartiles. Let's just run this. It actually does take a little while to run when I've set it to 1,000. So I believe this is n squared efficiency, because it has to look at every story and compare every POS count. So it'd be like 150 times 12,000 stories. It takes a little while. Maybe there's some way to make it go faster, but whatever. Well, probably the way to make it go faster would be to run it inside of my video card VRAM, but that sounds like a pain in the butt, so I don't feel like doing that. All right, I meant to turn this down to 100, I think, just for this purpose of showing, but whatever, 1,000 is fine. So, tuples with dog or cat. So I was curious how frequently these words appeared. So 374 stories contain the word dog that's used as a noun, part of speech, and 316 use the word cat as a noun. Now, apparently some of the stories use cat and dog as a proper noun. I'm not worried about those. This is what I'm considering a dog and cat exclusive story. So 113 dog stories, 55 cat stories. I'm wondering if this is counting each instance rather than counting it as a set, but whatever. Well, no, not whatever. Not whatever. That is not okay. Let's see where it actually loads the file. So that would probably be the only JSON.load in here. So all tuples equals unique items. Oh, I do a set. Well, oh, the initial counter is different than this. That's why I was getting confused. Got it. Nothing needs to be changed. All right. So, based on the scoring metric that I described, if you choose the worst set, then you get a score of 1150. And if you choose the maximum score, you get the best set is 2332. And these are the winner set parts of speech. So those would be the ones that we would focus on. That's really difficult for me. I don't want to focus on parts of speech. It's just like, hey, you want to learn a language, you got to learn all of it, right? So learn all of it, and that's the wrong way to look at it. You need certain type of specialization. You need to be able to talk about one subject and then move on to being able to talk about another subject. So the worst thing you could do, and this is the same mistake that I made multiple times, is just figuring out what the most common part of speech is, and starting with that, and then the next most common, and then the next most common, and then the next most common, because those are so generic that you can't actually form a sentence with them. So that's why I wanted to give extra points for if they can understand more of a story in context. I don't know, maybe I want even a bigger penalty for lower values. What if I did to the third? 0.8 squared is, 0.9 squared. squared. And obviously 1 squared is 1. What if we did to the third? 0.8 to the third is much lower. 0.5 to the third. You know what? I think I want to do to the third. Because, I mean, if you can only understand 50% of the words in a story, that's ridiculous. And I was just thinking to myself here, if you can understand a few stories here, then I think that that's much more important. Maybe I'd even go to the fourth. What would that be? Oh, yeah, 0.9 to the fourth. Look at that. That's exactly what I wanted. To the fourth is just squared, right? So I was halfway there. All right. Now that's going to radically invalidate these numbers here. So numbers of stories with 50% or more coverage, 3,837. 80% or more coverage, 5. 90%, 0. 95%, 0. 100%, 0. So what do you do? What do you do? The truth is, though, is my coverage would actually be better than that because I wouldn't be removing the things with the lowest coverage. Maybe setting the min to 0 would be better. Min occurrences is 15. What if we set it to 0? Then every word that doesn't matter at all is just suddenly going to be relevant in there. And maybe it really does make sense to manipulate this to, we take the best one and then we evolve it. It's like remove one, add one, remove one, add one. Maybe we could choose the one that helps the least and add the one that helps the most. Or I don't know, maybe we could let it go several different directions. We randomly pick one, see if replacing it helps, and then move on from there. It seems like this is going to very quickly become a lot of work. Yeah. Generate samples. Let's see what this does. Now, I've reduced the number of samples down to 100, so. Okay. With it down at 100, it should move much faster. So the minimum score is 178.33, and the maximum score is 554. The mean score is 339, and the quartiles are as such. Yeah. Now this is interesting. Setting that to 0 should have given us stories with 100% coverage, because the initial dog story and the initial cat story went in there. Something weird is going on here. And I don't like it. Min occurrences is 0. Okay, let's see. Everything from the dog story and the cat story. And then we say if it's greater than or equal to min occurrences, so it's already there. Oh, this is removing. Interesting. Wondering if I'm making a mistake here. Maybe I shouldn't remove. Okay. Well, I don't have time to make a evolving genetic algorithm tonight. I'm going to put a to-do in here. Revisit later. Maybe don't remove first story. No. You know what? I don't need 100% coverage. You don't need to learn the word max. That's a name. You'll get it. This should be a core curriculum. I need to be more open to that. Maybe initial of 250 is better. We're going to say num samples equals 3,000. We'll do one last run. Like I said, probably need some sort of evolving genetic algorithm. So, and I'm probably going to have to run it on the video card because this is way too slow. Okay. So let's see here. Write code to test that GPU automation is working with TensorFlow in Python. See if I screwed something up, which is entirely possible. Okay, let's see here. Probably done this before, but new. Do I have a scratch pad? A scratch pad. I do have a scratch pad. What happened? Why did it cut off? All right, let's see here. So, no GPU found. That is unfortunate. I probably messed it up when I was trying to get Mistral AI running locally, which is unfortunate. If I'd been able to get it to run locally and give consistent good results, then maybe I wouldn't have this giant friggin' bill. But, what do you do? What do you do? I actually realized that my code was calling everything twice. So it's almost double what it should have been because I copied and pasted a code snippet without really looking at it closely. And a piece of code that I thought was like an initialization was actually making another call. It was showing me two different ways to do it. So, and I don't even have a record of those calls. So it's not like I have, extra work that was done. It's just wasted. So, well, it doesn't take me long to waste money. Well, we won't be using a GPU today, that's for sure. So let's see here. Permutations. Oh my god, it's still running. I made it quite large, so... I need to get TensorFlow working again. I downgraded my version of CUDA, and that's where the trouble began. Look at how much difference there is between the minimum score and the maximum score. There's definitely a right answer. But can we do better than this? That is the question. And I have a feeling that we can. I kind of want to do it right now. It's too slow. I mean, it takes a very significant amount of time to run this. I wouldn't actually know how to write it in TensorFlow. I would rely pretty heavily on ChatGPT, to be completely honest, which is probably not ideal, but you know, what do you do? So let's say that our starting point is this, right? That is 250. That's our starting point. Now we want to know if we can improve on that by removing things and replacing them with something else. Now, what we would not want to do is we would not ever want to put something back that we had previously removed. That doesn't make any sense. So it's almost like we need two separate batches. We need invalidated, added, and removed, or something like that. Removed. Okay, so permutations, let's copy this, and then we'll call it evolve or something. I've got too many things open. Close other tabs. So we're going to load. We no longer need dog and cat exclusive stories. Most common 25. I don't think that matters. Yeah, but it doesn't matter the other direction either, so. So let's see here. Calculate score. I like that. We're going to need a calculate score. So count coverage of stories. I don't think we need that. This is our winner sample. Oh, I think I had a different winner sample. Which is the right one? It's the one that I just deleted, isn't it? Okay. Yeah, you can see. This isn't my first time doing this. Okay. Generate sample. This is gone. So calculate score. Calculate score, sample all files for sample in samples. So we're going to say print calculate score of winner sample for all files. And we're going to say s time. And then we're going to print the elapsed time. I actually don't know how long it takes. I imagine it probably doesn't take very long, but we'll see. Run. 0.064. All right. We need to convert these into numbers. So once we've discarded something, we're never going to... Once we've discarded something, we'll never consider that one again. We want to see if we can improve this by evolving it, by selecting other candidate words. Now, they would have to be common words, so let's see what the counts are of these samples. So we're going to have items equals, what is it? What's a counter? All tuples. So counter of k, comma, I guess k, for k in winner sample. sorted. Then for x in items, print x. Just show me what we've got, please. All right, so and is the most common, and then the least common is corner. So I don't think that it makes sense to look at any possible word with less instances than, you know what, I'm going to say 50. I'm going to say 50. So min option equals, I don't know, 50. And we're going to say for k comma v in counter dot items. I wanted it to autofill that time. So if v is greater than or equal to min option and k not in winner sample, then available items dot append k. So we're going to say print length of, not k, of available items, and then print available items, just show me what it is. So let's see what we got here. So we have 938 potential parts of speech that would be better in here. Now, what do we want to do one at a time, or do we want to do multiple at a time? And then do we want to test every unused part of speech, or do we want to, I mean, how much work would there be in testing replacing every one with one? That doesn't even sound that bad. What is the length of the not available items of the winner sample? Did I make it 250, 150? Okay. The calculation, replacing every single item with every available choice, taking 0.064 seconds, would complete in a few hours. What? I don't know why I can't type. Like I said, that's definitely too slow. Now maybe it would go a lot faster if I, went and changed these individual things. I just don't know. If I change these to integers, that's what I was trying to say. Okay. Can this do it for me? Probably. Doing it by hand sounds like a real pain in the butt. It sounds annoying. So I have a counter and an array of available items. I would like to... They are populated with tuples. I would like a mapping of integers to tuples bidirectional and replace the values with the integers, since I expect integers to compute faster. Please provide bidirectional conversion methods and code to make new converted data structures. Create bidirectional mapping between integers and tuples to replace the values in available items in array and counter with integers. You can follow these steps. Should already have that imported. Okay, counter and available items. You know what? This wouldn't have been too hard to do by hand. Maybe I should have just done it by hand. Converted back to tuples. So yeah, okay. So convert to int, convert to tuple. Okay, we don't need that, we don't need that. Let's just see if this works. Run. Okay, so converted to available items. All right, awesome. Converted back to tuples. Have spoke. All right, cool. So now we have the integers. Now we should be able to do the substitutions more easily. Can I call score? Calculate score, sample all file. Oh, God. All right. All files is unique items, which is a set. All right. Write code to convert a dictionary of sets of tuples to a new dictionary of sets of integers according to the mapping. All right. Here we go. Okay, convert dict of sets, original dictionary tuple of int magic, converted key tuple set, converted set. That's pretty friggin' convenient. Okay, so convert dict of sets. We're going to have original dictionary, tuple to int mapping, and then we're going to have all items converted equals convert dict. No. Convert original dictionary is all items. All files? Was it all files? If it was all files, then it should be all files here as well. All files converted, and then here. Converted counter. Converted tup. Is that right? Print all files converted dot, I don't know, dot pop. Pop expected at least one argument, got 0. I hate you. I hate you so much. All files converted dot keys list 0. I don't think that we need this. This is a little bit silly. All right, run. Okay, so this is absolutely all filed. All filed? This is absolutely not converted under any set or definition. So converted, is it just showing me the original? K equals this. Run. Absolutely, nothing has changed. So converted set equals tuple to int mapping tuple item for tuple item in tuple set. Exactly. So tuple to int mapping tuple to int. This should work. Something weird is going on here. Yeah. Yeah, if it was failing, it shouldn't be giving us anything. Look, this is an array, and this is a set. Tuple item in tuple set. Key tuple set in original dict dot items. Original dict is... Oh, wait a minute. It's actually a tuple list. Okay, no, this is right. This is right. Converted dict key. How is this not converting things? Tuple to int mapping. This should be working. Tuple to int mapping. Did I pass the wrong thing? Tuple to int. I don't know how that worked at all. Is this real life? I just completely passed the wrong entire variable. So here we go. This is giving us a set. And I'm pretty sure we want it to be a set. I think that even if it was originally a list, we want it to be a set. So now let's see if we can do the scoring. Calculate score, sample all files. So calculate score is going to be provided set and then all files converted. All files converted. Right? Sample dot intersection with story position set. Intersection story position set converted values. This might actually be a lot faster. So print calculate score of not all files converted. What did we do with winner sample? We never converted winner sample. Unique tuples equals set counter union set available items. Why am I stupid? So available items was converted, right? Converted available items. Where was it converted? For item and available items. So converted winner set it should be a set is in winner set, winner sample. So we come down here, calculate score of converted winner set, and run. Is that the same score? I think it is. Print. I am printing too many things. I think that's the big one. All right, so 1190. Okay, it is working. And hopefully it's faster. So, I wonder what ChatGPT would do if we just asked it to evolve for us. Okay. Okay. We have a scoring method and a current known optimal set. We would like to evolve the set by replacing numbers in the set and then recalculating the score. It might be easier to convert the set to a list for the purpose of evolution and then make it a set before calling score. Do you propose a better evolution algorithm? Evolving a set by replacing numbers and recalculating a score sounds like an optimization problem where you're trying to find a set with the best possible score. The approach you described is somewhat similar to a random search algorithm where you randomly alter the set and check if the new set has a better score. However, this method can be inefficient, especially for larger sets or more complex scoring functions. A more structured approach would be to use a genetic algorithm or simulated annealing algorithm. These algorithms are more sophisticated and can potentially find better solutions in a more efficient manner. Here's a brief overview of each. Genetic algorithm. Initialization. Start with a population of sets, including your known optimal set. Evaluate the score of each set and select the best performing sets. Crossover. Combine elements of these sets to create new sets. Children. Mutation. Randomly alter some elements in these sets to introduce variability. Repeat the selection, crossover, and mutation steps for several generations. Termination. Stop after a fixed number of iterations or if the improvement falls below a threshold. Simulated annealing. Start with your known optimal set. At each step, make a small random change to the set. Calculate the score of the new set. Decide whether to accept the new set based on its score. That sounds like exactly what I was defining. Temperature parameter that decreases over time. This allows the algorithm to escape local optima in early stages. Stop after a fixed number of iterations or if no significant improvement is found. Converting the set to a list during the evolution process is a good idea. It allows for easier manipulation. Just convert back to a set before scoring. If your scoring function requires a set scoring function, ensure your scoring function is efficient, as it will be called numerous times. Both algorithms, I guarantee you it's not efficient. That's the frickin' problem. Have to tweak based on your specific problem. These algorithms provide a more directed setup. This is pretty much exactly what I was talking about. So I don't mind having, multiple different sets. Any set, man. We can set up chromosomes or something. No, I don't think that that's necessary. I think that we can do the random substitutions and we can just see where it goes. What we need, though, is we need to make sure that we don't reintroduce something that we've taken away before, because that doesn't make any sense. I'm actually curious about just trying every single replacement every single time. Maybe that's a bad idea. I don't know. So do we do the random or do we do the brute force? Just doing brute force just sounds like it makes more sense. All right. Okay, converted winner list equals list of converted winner set. Okay. Converted winner list equals list of converted winner set. Okay. I don't have multiple starting sets. Create no, we're just gonna have one, and we're gonna convert it. So okay. Here's my starting point. Make a method which returns a new list. Make a method which attempts an evolution and returns a new list if a better was found, and returns none if the attempt failed. Returns a new list and the new score if a better was found, and returns none, none if the attempt failed. Okay, to create a method that attempts to evolve converted winner list to find a better score, we'll follow these steps. Randomly modify the list by replacing an element with a new random integer. Calculate the score of the modified list. Compare the new score with the score of the original list. If the new score is better, return the new list and new score. Otherwise, return none, none. Here's an implementation in Python. All right, converted list, calculate score, all files converted. Oh, we have available items. Converted available items if item not in converted winner set. Converted available items. Converted available items. I forgot to mention, we have a list of candidate known to not be in converted list. I forgot to mention we have a list of candidate items known to not be in converted winner list. I would like to remove items from that list as they are attempted. Maybe they can be attempted 3 times or something. But if it is used, then it should be removed and never tried again. If it fails 3 times, then it should also be removed. Please make the modifications. To modify the evolution method to incorporate a list of candidate items and track their usage, we can implement a system where each candidate is attempted up to 3 times. If a candidate leads to an improved score, it will be used and removed from the list. If it fails 3 times, it will also be removed. We'll need a mechanism to track the number of attempts for each candidate. Here's an updated implementation. I'm wondering if these are going to work. Attempt tracker, candidates, new list equals new score. This is interesting. Paste. Okay, all files converted is never used. It's not a good sign. Candidates. Where is it? Converted available items. Attempts tracker, new list. Is it going to work out of the box, or am I going to have to change something? Evolution successful. New score 1196,878. Okay. New list, new score. I want this to make a new list so that it doesn't destroy our original. I'll say I for I in converted, and then we will say while candidates candidates. So we have an initial score of 1190. I think the decimal can be ignored. Let's see what you can do. How could it ever go down? Something is wrong here. New evolution successful. Oh. Then converted winner list equals new list. Yeah, I'm like, it should be going up. If the evolution is succeeding. Oh my God. Well, what? Is there no limit? Oh, it's trying every candidate. Okay, that's why it's slowing down. This is awesome. To think I was considering skipping this step. Evolution attempt failed. Evolution attempt failed. That is a drastic increase. That is awesome. Why did I not print the friggin' print converted? No, I need to convert it back. So how do we convert it back? Why did I not print it? That was so stupid. Convert to tuple. So yeah, we're going to have, if it gets worse, I'm going to be sad. Convert to tuple I. I mean, if it's not at least this good, then I'll want to repeat it again. So, for in converted winner list. Now, let's run this again. And let's see what it gives us. Come on. Come on. I mean, obviously, I won't accept less than this. So what I could do is I could run this script like 500 times. Not in one sitting, obviously. But I could run this script multiple times. And then from there, I could, choose the best from all of those. And I think that I would be much closer to, an actual right answer. So winner sample. Winner sample. So yeah, so we should start with 1776.54 whatever, and now evolving should be much more hard, or not. God, there's no limit. There's no limit to how much this is going to improve. I have to be careful that I don't put too much faith in the scoring algorithm, because I've run into that kind of problem before, where I get so caught up in a number that I forget to take a step back and look at the bigger picture. Evolution attempt failed. Evolution attempt failed. All right. Is there no limit to the wonder? Well, I mean, eventually we're going to start getting reduced. Eventually we're going to start honing in on what the best set is, right? We're not. This is too much fun. I could just sit here and keep messing with this. Maybe I just need to set it on a loop. Just have it run 100 times like this. Sorry if this is boring. 1980. Remember, I'm like, I can't be less than 1768. All right. Where is it? Okay. Okay, we've got to be reaching some sort of a limit, right? The gains are smaller. But I think you can see how this would really, really benefit from being able to run yeah, like on a GPU or something. Okay, 2012. Okay. Evolution attempt failed. I mean, I'm expecting at some point we would be close to. Oh my god. It removed dog and cat. Absolutely unacceptable. Maybe I'm making a mistake. Maybe I could choose the best combination of words and just artificially shoehorn dog and cat in there. And you know what? Maybe that is just fine. Or maybe I should choose what seems to be mathematically best. I mean, I was the one who said it had to have a dog and a cat in it. I think I was trying to prematurely optimize marketing because I know that that's not something that I think about. I know that that's not something that I'm worried about. And you know what? Maybe I should be. The process you've implemented can be summarized as follows. A randomized optimization technique that iteratively improves the solution by selectively. The process is not a classic genetic algorithm as it lacks typical genetic algorithm components like population crossover and mutation. Single solution based stochastic search where random alterations are made to a single solution and improvements are kept. This approach combines single solution stochastic searched. Is it wrong to use the word evolve for this context? Using the word evolve in this context is not wrong, but it might be slightly misleading if interpreted in a strict computation or biological sense. In the field of evolutionary algorithms, evolve usually refers to okay. It looks like we're getting pretty close to the limit here. I can't help myself until it returns nothing. I can't believe that number just keeps going up and up and up. Alright. Is it trying everything and it's failing? Oh well. Iterative improvement or stochastic optimization. Alright. Hey, look at that. Okay, I swear this is the last one. I won't do another one after that. Oh my god, look! It jumped by 4. It jumped by 10. That is not negligible. Evolution attempt failed. I'm curious. I want to look at what it's honing in on. Specifically the nouns. All right. Okay, here's what we're going to do. We're going to copy this line, and then we're going to go to Scratchpad. The rule for Scratchpad is anything in here can be deleted, no questions asked. If I wanted to save it, I needed to save it at the time. So let's say default dict of list. What are you doing? Stop it. Okay, we're going to say d equals default dict, and then we're going to say for part of speech lemma, no, word lemma in winner sample, and we're just going to say d of part of speech dot append. I don't want the lemma. Okay, and then for k comma v in d dot items, I just want to see what's in here. Print k v. Just show me the items, because I want to see what time, people, heart, others, animals, place, team, eyes, friends, laughter, night, town, birds, children, memories, life, forest, kids, clock, kindness, garden, stories, house, face, world, trees, home, village, happiness, morning, sun, family, love, day, fun, things, sky, land, joy, smile, care, group, hand, man, girl, park, work, friendship, school, friend, room, boy, adventures, adventure, city, games, lots, way, flowers. I think we are approaching a level 1 curriculum, and I am happy. Wow, a proper noun made its way in here. I was not expecting that. Okay, is there punctuation, or did I exclude that at some point? I think I excluded that. If there were punctuation in there, I would want it excluded. So, around with, up by, for, like. This is great. This is wonderful. I mean, I think that I need to evolve this a few more times, and I need to make sure that, you know, is this used? I don't think this is used anywhere. Is this used? So, yeah. I think I'm getting pretty close. Having thousands of stories ready and a preset curriculum, I can't do willy-nilly. I have to have, you know, a guiding set of words that I'm targeting for. It's the same problem I made with the reading program like a decade ago. It's just like, oh yeah, always have to know every single word all the time. And then you can't prioritize and say, no, you really do need to focus on core words, especially if you're struggling with them, and you really do need to give up on some weird esoteric crap that made it into the curriculum because you said, oh yeah, a university student would know that word, so it should be in there. So, yeah. Now, what I'm going to do is, obviously it has to be incremental. So we start off with the first 250 words, and then that'll be static. We won't be able to change that. But then, we'll add to that the next, I don't know, 500 words or something. Or maybe we'll do another set of 250. Or maybe it'll even be smaller. Maybe after that it'll be chunks of like 100 or something. And then from there, we continue to move forward until we reach our destination. I don't really know what this language program is going to look like, and I'm pretty doubtful that anybody's actually going to use it. But I want to make the best that I can make. So hopefully the AI stories that I've made are not too awful, and I am toying with the idea of having a truly dynamic curriculum where you don't have a set story to read. If you're struggling with one word, you will keep getting different stories to review that word. I mean, obviously, there's some limit. There's the limit of the number of stories that appear, but I mean, every one of these what did I put the minimum at? Like 50 or something. So like every single one of these appears in at least 50 stories. So and I think the word time appears in like a ridiculously large number. Actually, what is the max word? I think that would be interesting. Interesting to know. So I load all of these in, and then I make a counter of all of the tuples. And let's just do most common 20. Most common 20. I had originally printed these out, and then for k comma v in most common 20, print k comma v, and then instead of exit, we'll do assert, because that way I'll realize that something is wrong. So let's see what they are. And the into day. So this is the most common noun. There, they, with, of, one, was, auxiliary, and verb. Okay. I would probably have counted that as one word, but learning it as two separate parts of speech presumably would make the second one easier to learn, so that's fine. Pronoun, adverb. But you do have to address different parts of speech. For example, the word dove, like the past tense of to dive, and dove are pronounced completely different, and they have completely different meanings. So if you treat them as the same word, you're going to run into a situation where, what do you do? Now, when I was making the reading program, I didn't have Spacey to give me parts of speech. Now, it's okay if it makes a mistake sometimes, as long as, the 90-10 rule. As long as 90% of the time it can be getting it right, or if it's consistently making the same error, it doesn't matter as long as there's coverage in my program. And if some error causes one word to not be taught, well, that's fine. I'm not trying to teach every word in a language. I'm trying to teach the language. So I'm hopeful, because I felt kind of paralyzed for a while. It's like, how do I move forward with this? And now, with my curriculum and with my stories, all I need are a set of sample sentences which span the words that I'm trying to learn. And I believe that I can get those from the corpus. That shouldn't be particularly difficult. I know that I've shown this before. But I actually have gotten a lot of words in the past. Yeah, no, what? So yeah, if we're looking for a sample of, well, just anyone. Here, let's do this. Of course, it's nothing like it's supposed to be. Yeah, here. Where are they? There's your sample sentence right there. Or who are they, or what are they doing, or they're here, or they're coming, or where are they, or here they come, or there they are. So yeah, maybe I can't use this for every word, but I can use these sample sentences, and there's no issue with copyright because this appeared in 143 different works that I parsed. So that the phrase is so common that it doesn't matter. And the truth is, a sample sentence taken out of context would definitely classify as fair use. And I've got quite a few of these. I mean, thousands. So, yeah, sure, maybe it's not every word, but I could go out looking for other sentences as well if I needed them, or I could generate them. I generated thousands of stories. I could certainly generate sentences in a like manner. So, anyways, that's awesome, and I guess I'll see you later. So, definitely not going to make another video tonight. I've already done more than I should, and I need to work on my class. So, okay, bye.